We're surrounded by data all day, every day. But have you ever really stopped to think about the rules it plays by? Well, it turns out there's this hidden logic to all this information, and once you see it, the world of numbers and charts starts to make a whole lot more sense. So today, we're going to decode those surprising rules together.
Okay, to get us started, let's think about a basketball team. You've got jersey numbers, right? Like 23, 33, maybe an 8. So here's the puzzle. Why is it completely, totally meaningless to calculate the average of those numbers? Just think about that for a second. By the time we're done here, the answer is going to feel incredibly simple.
All right, the first major clue to solving our little jersey problem lies in this really fundamental split in the data world. See, pretty much all data can be sorted into two big buckets: data that describes qualities and data that measures quantities.
So on one side, you've got qualitative data. This is all about descriptions, stuff you can't really measure with a number. We're talking about things like eye color, the brand of your phone, or your favorite type of movie. And then on the other side, you have quantitative data. Now, this is anything you can count or measure: your height, the temperature outside, or how many unread emails are sitting in your inbox.
Now, this is where it gets pretty interesting, because out in the real world, these two types of data are almost always hanging out together. Just take a look at this table about sports-related head injuries. Can you spot both the qualitative and the quantitative data hiding in there? First, let's look at that left column. The names of the sports, basketball, football, soccer, those are qualitative data. They're not numbers we can measure. They're just labels, plain and simple. They're just different categories. And now, of course, look at the right column. Those numbers, the counts of head injuries, that's our quantitative data. These are actual, real numerical values that we can compare and do math on. So here's the crucial point. One is just a label, the other is a measurement.
But, just knowing if data is a quality or a quantity, that's not the whole story. To really get what we can do with it, we need to get more specific. I want you to think of it like we're climbing a ladder. Each rung we step on gives us a more powerful way to look at our information, and there are 4 levels we need to know. And here they are. From the simplest to the most complex, we've got nominal, ordinal, interval, and ratio. Each step up this ladder is going to unlock new things we can actually do with our data, especially when it comes to the math.
Let's start at the very bottom with the nominal level. This is the most basic level you can get, and it's for qualitative data only. Really, just think of it as putting things into labeled boxes. Like movie genres: action, comedy, drama. Sure, you can count how many movies are in each box, but you can't do any math on the labels themselves.
Okay, taking one step up the ladder brings us to the ordinal level. Now, all of a sudden, order matters. We can now rank our data, first, second, third. But here is the key catch. Even though we know the order, the gap, the difference between the ranks, isn't consistent or meaningful.
This list of top occupations is a perfect example. We know that rank number 1 has more job growth than rank number 2. But the difference in growth between number 1 and number 2, that might be huge, while the difference between number 4 and 5 could be tiny. The rank gives us an order, but it doesn't give us a consistent scale.
Okay, so now we get to the top 2 rungs of our ladder: interval and ratio. This is where things get really, really interesting. And the biggest difference between them comes down to one single powerful idea: what the number 0 actually means. Seriously, what is the big deal about 0? I mean, it turns out, in the world of data, not all zeros are created equal. Some zeros mean nothing, just a total absence of something, while other zeros are just a placeholder on a scale. And understanding this, well, it's key. This brings us to the concept of an inherent zero. That's a zero that means a true nothing. Think about it. $0 in your bank account means you have literally no money. But contrast that with temperature. 0 degrees Celsius doesn't mean there's a complete absence of heat. It's just a point on a scale we all agreed on. That's the difference right there. And this exact distinction is what separates our top 2 levels. At the interval level, you can order the data, the differences between the values are meaningful, but 0 is just another point on the scale. But at the ratio level, you get all of that plus an inherent 0. And that little change opens up a whole new world of calculations you can do. This is exactly why temperature is a classic example of interval data. You can't say that 10 degrees is twice as hot as 5 degrees. That doesn't make any sense. But precipitation, on the other hand, is ratio data. 2 inches of rain really is twice as much as 1 inch of rain, because 0 inches means an absolute total absence of rain. That inherent 0 is what lets us make those powerful twice as much comparisons.
Okay, we've climbed the ladder. We've separated qualities from quantities, and we've walked through all 4 levels. So now, let's put it all together into one simple, powerful cheat sheet that sums up everything we can and can't do at each level.
Look at how this table lays it all out. At the nominal level, we can only put things in categories. Step up to ordinal, and we unlock the ability to put things in order. At interval, we can now subtract values to find meaningful differences. And then at the very top, ratio, we can do it all, including making those powerful comparisons like twice as much. Each step up the ladder gives us a new analytical superpower.
And that brings us right back to our original puzzle, jersey numbers. So what level are they? Well, they're just labels assigned to players. There's no real order. Player number 30 isn't necessarily better than player number 20. They are classic textbook nominal data. And as our cheat sheet just showed us, you can't perform mathematical computations on them. And that's it. That's why averaging them is completely meaningless.
Now, this isn't just some abstract theory. Understanding these levels has huge real-world consequences. So let's wrap this all up with the most important question. Why does any of this actually matter?
First and foremost, it's about being accurate. Knowing the level of measurement stops you cold from making really common but pretty significant mistakes. It keeps you from doing things that just don't make sense, like trying to find the average zip code of a city or, you guessed it, the average jersey number on a team.
But beyond just avoiding mistakes, this is really the first step to thinking critically about any data you ever come across. From now on, whenever you see a chart or a statistic, you can ask the single most important question: what level of data is this? And that question alone gives you the power to separate valid insights from statistical nonsense.
So I'll leave you with this thought. Now that you know the hidden rules of data, start looking for them everywhere. Is the star rating on a product you just bought ordinal? Is the price of that product ratio? When you start seeing the world through these levels, you'll be absolutely amazed at how much clearer everything becomes.